Okay, so the beginning of our next unit is going to introduce us to a couple of new basic functions. If I can get that stuff to disappear off the screen. There we go. So we've spent a bunch of time with our 6 basic functions. We've learned to move them all around and to stretch them and to shrink them, do all sorts of crazy stuff. So now we are going to add a couple new functions to our repertoire. So that's what chapter 5 is going to be about, is different types of what's called rational functions. Okay, so starting off real quick, just so that you know, again, you likely have seen rational functions before. I don't think it's too much of a mystery. You might not like them, but I think you've seen them. So a rational function is of this form. It's f of x, okay, our function is equal to, rational numbers are fractions, so rational functions are fractions that are made out of functions. So that sounds very exciting. So we're going to have a polynomial in the top, and we're going to have a polynomial in the bottom. That's the general format of every rational function. Okay, so I'm just going to let you know for your notes where p of x and q of x are polynomials. And then there is one caveat that's going to come up over and over. You're probably used to this from arithmetic. You cannot have the denominator of a fraction be 0. And so that is going to be something that impacts the domain of our rational functions. We'll talk much, much more about that. That's going to be good times for all of us. So we have this caveat that the denominator, q of x, cannot be equal to 0. Okay, so I'll give you a moment to catch up on that, and then we're going to graph our 2 new friends, and we're going to then review our translations and our stretching and shrinking with our 2 new functions. So we're going to do 2 things in the next 2 sections. The first thing we're going to do is we are going to be given a couple basic functions, and we're going to treat it like we've done everything else. When we get to the next section, though, not every rational function can easily be written in the format of one of our basic functions. So we're going to go through another process to graph these as well. Okay, so the first one is called the reciprocal function. It is 1 over x. So 1 over x just means whatever number you plug in for x, you're taking the reciprocal of it. Just like we did in the past, though, I'm going to make a little table to help us get used to these values. So here on the side, I'm going to squeeze in a little XY table for us. And I'm just going to plug in some values that are going to help me be able to see what the general shape. Now, we're just doing some nice little sketches of these. You don't have to be super detailed, but I do want to see these few points, okay, or something thereabouts. So for instance, I'm going to plug in these values. We're going to start with 2 and 1 and a half and then 0, and then the negatives of those, negative a half, negative 1, and negative 2. We're going to plug those in, and we're going to see what happens with my reciprocal, my 1 over x with each of these values right here. So function f of x, whatever x I plug in, the output is going to be 1 over that x value. So knowing that, help me out with the table. When I put 2 in, what is going to be the function value at 2? Perfect, 1 over 2, 1/2. So 1 over 2. Great job so far. We're 1 for 1. When I put 1 in, what is going to be my function value at 1? 1 over 1, or just 1. Great. Excellent work so far. The next one, when I put a half in, what's my function value going to be? Okay, I heard one person say it, so I'm not feeling super confident. So just following the same pattern, it's going to be 1 over a half. And you can take out your calculator. If you take 1 and then you divide it by 0.5, okay, it's going to be 2, as was already told to me. This is called the reciprocal function. So whatever you're plugging in, you're just going to take the reciprocal. So that is equal to 2. So when I put a half in, I get 2 as the output. So just because I want to go into the weekend feeling super confident that you're hearing me, if I put 1/5 into this, what is going to be the function value at 1/5? 5. Okay, we got a few more people participating. That's great. 0. When I put 0 in, what's 1 over 0? It's not 0. I know that's our reflex. It's not 1 either. Ah! Okay, so let's go up here. Let's do a real quick review of fractions. So if I have 0 divided by 1, remember, a fraction bar just means division. So I have the number 0. I'm dividing by 1. So what number up here times 1 is going to give me 0? Well, that's 0. Basically, this is the situation. You have $0 and you want to divide it among your friends. You're going to give them each 0. Okay, that's real world for me, okay, as a teacher. Great. So now here's where we are stumbling. 1 divided by 0. So I'm going to take the number 1 and I'm going to divide it by 0. So here's the question. What number up here times 0 is going to give me 1? 0 times 0 is 0. So that's not going to be quite it. In fact, whatever number I put up here, okay, so any number that I put up here times 0 is going to give me what? 0. I am never going to get a value that's not 0. So I can't break this 1 down. Okay, I can't get anything close to it. So that's why when we divide by 0, we say that it's undefined. Okay. Numerically, dividing by 0 can't be done because just for this reason, any number that I would put at the top to multiply by 0 is going to give me 0. It's not going to give me any value. So going back down here to my little XY table that I have and I'm creating. So for 0, I'm going to put undefined. I'm going to abbreviate right there, undef. All right, hopefully the rest of these values are not too big of a deal. I knew that that one was going to be fun because every class we have to go through that. I understand we kind of just get lulled to sleep by dividing by things. Okay, if I put -1/2 in there, what's the reciprocal of -1/2? Perfect, -2, great. When I put -1, what's the function value at -1? Yep, 1 over -1. 1 divided by -1 is just -1. And last but not least, what is the function value at -2? What am I going to get? -1/2 or -0.5 if you're fond of decimals. All right, I'm going to plot these points, and then I'm going to tell you a little bit about our reciprocal function, the first of our rational functions we're going to talk about. So when I go over 2 hops, I go up 1/2. So we're just going to be right there between 0 and 1. When I go over 1 hop, I go up 1 hop. When I go over 1/2, I go up 2. I'm not going to connect the dots yet. We'll wait on that because I'll tell you what I'm looking for when I grade your test on this. So now the same thing backward. When I go back 1/2, I go down 2. When I go back 1, I go down 1. And when I go back 2, I go down 1/2. Okay, the first important thing for you to note as you're getting to know your new friend, the reciprocal function, is that the x value 0 were undefined. So what we have at the x value 0 is what's called a vertical asymptote. If you've never heard that word asymptote before, make yourself a little note. A vertical asymptote is an x value that the graph never goes through. It's an x value, a vertical asymptote is an x value the graph never goes through. Now, I know it's not going to be great. You're not going to be able to see it really well because of our x-axis and y-axis here. But the way graphically we denote that we have a vertical asymptote is I'm just going to draw a dotted line here and trying to make it so that you can kind of discern it. Okay, there's my dotted line. Somewhere on your page, I want you to write this. This will be good information for you. A graph never goes through a vertical asymptote. It is a force field. If you like Star Trek or Star Wars, you're just going to bounce right off it. Okay, you can never go through a vertical asymptote. So what that means, I'm just going to do the right side of this graph. What that means for this graph, I'm not going to worry about what happens going down just yet. I'm just worried about as I go back toward that vertical asymptote, what's going to happen is the graph's just going to keep getting closer and closer and closer, but it's never going to quite touch. Okay. So I wouldn't draw too far up, because the temptation that students have is, because you start getting close to the y-axis, you start freaking out a little bit, and then you start drawing the graph curving back outward. And the graph does not curve back outward. Okay, if we had a microscope, the graph's just going to keep getting closer and closer and closer and closer and closer to the y-axis. So I'm not going to draw any further, because I don't want it to look like, I'm just going to try to put a little arrow at the top just to let everybody know it keeps going like that. And the same thing happens on the other side, on the left side of this vertical asymptote. The graph's just going to keep going down, 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 down like a rock. Again, it does not curve outward, so please don't do that. That's one of the things I look for when you're graphing your thing on the test. So what I mean by that, just so that we can be super clear, because I don't want you leaving here feeling any sort of confusion. What that means is, when you're graphing this on your test, here's your points that you've got. Don't do this. Don't go, ooh, oh, 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 like that. Okay, that's wrong. That's not what the graph looks like at all. So just make note to yourself, please. Okay, so now we have to talk about what's happening as the x values get bigger and bigger and go from 5 to 10 to 100 to a billion. So we didn't find these values, but let's, if you want to use your calculator, let's just do a little thinking here. If I put 5 in, what's the function value at 5? One over 5, perfect. No trick questions here, it's just 1 over 5. Remember, this function, whatever the x value is, I'm just stick it in the denominator. So when I put 5 in, the result is 1 over 5, or 0.2. Well, how about if I put 10 in? What's the result when I put 10 into this? 1 over 10, or 0.1. So notice what's happening to these y values. They're getting what? They're getting smaller and smaller and smaller as the denominator gets bigger. So if I put, like, if I had a piece of graph paper that was big enough and I could go way, way, way out to the right, what if I put 100 into the graph? What's the function value at 100? 1 over 100, or 0.01. So it's small, but there's still a little bitty bit. So if I put a billion in there, the function value is 1 over a billion. It's still a little bit. Okay, so what this means is I'm never going to get 0, because I always have 1 over something. And so the graph is going, it's like a plane that's never going to land. It's going to keep getting smaller and smaller. Again, I'm not going to go much further, because then it's going to look like I'm merging with the axis. The graph is going to just keep going in that direction. And the same thing happens as I go backwards. I'm always going to have a small fractional little bit. And what we have here, the x-axis is what's called a horizontal asymptote. Now, horizontal asymptotes are not as definitive as vertical asymptotes. What horizontal asymptotes are telling you is what's happening as the x values get really, really, really big. When you take pre-calculus, those of you who will, you're going to start to learn about what's called a limit. You're going to spend a lot of time talking about limits, and that's basically the visual concept of a limit. Okay, this as the x values get bigger and bigger and bigger, the y values are going to get closer and closer to 0, but they're never going to be 0. 0 is what's called a limit. You don't need to know anything about limits here. I'm just trying to relate a concept you're gonna think about in your future. So that there is my reciprocal function. It's another one to practice. There's blank graph paper on Canvas. Sometime over the weekend, please, I beg you, take this seriously, because this is what the next test is going to all be about. Print out a piece of the blank graph paper and just practice doing this a couple times so that you're familiar with it. So in the meantime, though, you've got your basic points. They're right there next door. I want you to exercise 1. I'm going to leave the basic graph there. If you need to reproduce it in pencil, that's great. I'm going to do the same thing. I want you to then graph what is my 1 over x, but then I've got a +3 that's on the outside of it. Actually, let's do this. I'm going to give you 20 seconds before you even worry about graphing it. I want you to make a hypothesis. What is this +3 doing to the graph? So write down, just right next door, what you think that +3 is doing to the graph. Okay, so there's really two options. What do you think this +3 that's out to the side is doing to the graph? Yep, it's making it go up 3. Okay. It's the same thing as when I have back in the day when we had x squared plus 3. When the +3 was outside of the x squared, that meant bring it up 3. So that's what we're going to do. So I'm going to give you a couple minutes. I want you to do two things. I want you to reproduce the basic graph, and then I want you to take the basic graph and move it up 3 units. All right, so here we go. Here is my basic graph right here. I've just reproduced those points that are on the table that hopefully you put on your paper, or maybe you redid just to practice it. And now I'm going to take these points and I'm just going to move each of them individually up 3. Okay, so I'm going to start over here on the right at this, the y value is 1/2. So 1, 2, 3, it's going to be 3.5. This one's going to go from 1 up to 4. This one's going to go from 2 up to 5. Similarly, on this other side, this is going to go from -2 up to 1. This is going to go from -1 up to 2. And finally, this is going to go from -0.5 up to 2.5. One more thing I'm going to do is, since I brought the whole graph up 3, that horizontal asymptote is also going to move up 3. So this is going to help me. I'm just going to draw a cute little dotted line right here, dot, 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 all the way across. That's my horizontal asymptote. Since I did not move the graph left or right at all, the vertical asymptote is going to stay right where it is. So I'm just going to do some red dots right here in the middle. And now I'm going to connect the dots. So again, just a little sketch. You don't have to go overboard with it. Don't go too far and mess up your graph. There it is, right there. There's my little sketch of f of x is 1/x plus 3. All right, before we go on to the next one, because we're just going to practice this a few more times, is there a question so far? All right, well, I trust your judgment, although I probably shouldn't. Here's the next one. F of x is equal to 1 over, now notice where the -4 is. The -4 is in the denominator with the x. So I would like you to take 20 seconds. I want you to theorize right above. What do you think that -4 is going to do to this particular graph? And what did you write down? What's going to happen with this graph with that -4 attached to the x? It's going right 4. The whole thing is going to go in the positive x direction 4 units. And yes, as was said to me in that answer, that vertical asymptote is going to go right along with it. So I'm going to give you a couple minutes. Go ahead and, again, reproduce the basic graph since this is our first day doing it. And then take that whole thing right 4. All right, I'm going to get started on my basic points here. So I'm just using the table that is up above on my sheet. Hopefully it's on yours. I'm going to go over 2, up a half. I'm going to go over 1, up 1. I'm going to go over a half, up 2. And then there's the right half of the graph. And then I'm going to go back a half and down 2, back 1, down 1, back 2, down a half. And here's the left part of the graph. I'm not going to pencil in the asymptotes. They're just the x and the y axis in this case. Now I'm going to take the whole thing right 4. I'm going to move every one of those points 4 units to the right. So here goes. So this one, instead of being a 2, goes out to 6. This one, instead of being at 1, goes out to 5. This one, instead of being a half, goes to 4.5. My vertical asymptote is going to go out to the value 4. So I'm going to make a cute little green line right here. So there is the right half of the graph. The horizontal asymptote has not moved. We've not moved that graph up or down at all. And then the left half of the graph, this goes from -0.5 to 3.5. This goes from -1 to 3. And then finally from -2 to 2. And here is the other side of that graph right there. Nice, cute little sketches of these rational functions. Okay, we've got one more, and then I got just a couple of final things of trivia about the reciprocal function. Before I move on, any concerns? Anything I can do to clear anything up for you? All right, well then exercise 3 right next door. One more time, 20 seconds, write down what is going to happen to the graph of my basic reciprocal function with this. Well, I guess you're supposed to answer a question for me. Sorry, that's way more than 20 seconds. So what two things are happening to this graph? You probably already have graphed most of it. Okay, it's going left 2. The +2 in the denominator means going left 2, and then it's going down 4. So just another minute or so, and you can finish that up. All right, so we're taking this whole graph, left 2, down 4. So here I'm just going to start the left side this time. So left 2, and then 1, 2, 3, 4 down. So I'll make a dot. Left 2, and then 1, 2, 3, 4 down. Another dot. And then left 2, and then 1, 2, 3, 4 down. Perfect. My vertical asymptote is going to go left 2 as well. So I'm going to make a cute little pink dotted line right here. Whee! And then my horizontal asymptote is going to go down 4. As you get better at doing this, you'll notice that when the horizontal and vertical asymptote moves, it's kind of like the whole X and Y axis move. You basically you can use that now for your basic points, but that takes a little getting used to. So then once again, left 2 and down 4. So 2, 1, 2, 3, 4. There's my first dot, and then left 2, and then 1, 2, 3, 4, second dot, and then left 2 and 1, 2, 3, 4. There's my third dot. And so there's the right part of the graph, perfection. All right, so two quick things before we flip the page. You go to the other half. My original reciprocal function, this is going way back. Is this an even function, an odd function, or is it neither? Can we tell visually? Well, it's been a while, hasn't it? What's an even function? What does that mean? How can I tell just looking at a graph if it's even? Not above the x-axis. What'd you say? I just didn't hear what was being said back there. Oh, everybody's all shy and scared today. It's symmetric. If it's even, where's it symmetric? Anybody remember? The y-axis. I can fold it. Is this graph symmetric about the y-axis? Can I fold it on the y-axis and have the same thing on both sides? No, it's not even. How about odd? Does anyone remember what odd means? What is it symmetric with respect to? The origin. And what was the visual test? It wasn't folding it. If it's symmetric about the origin, what can I do to the graph? I can twist it 180 degrees. So I'm going to put my pen right here at the origin. Oops, if I can not make a big mess. And let's flip it and see, is it the same thing? Is that the same graph when I twist it 180 degrees? Yes. So this is odd. Okay, so this is an odd graph. Your basic reciprocal function is an odd graph. And I just want to real quick mention the domain and the range, because with rational functions, our domain and range starts to get interesting. So I'm going to do this for the original basic function. Then I'm going to have you do it for one of the other functions just to identify. Yes. No, not when you move them. That you change when you do translations, you change the symmetry as well. So it's kind of like our parabolas in the last unit. When we moved the parabola left or right, we moved the line of symmetry left or right as well. So that's a great question. Okay, so for this one, my domain. So looking left and right, as we do when we're looking at the domain, how far left does this graph go? Okay, negative infinity, perfect. But then as I'm moving along the x-axis, is there an x value that I have to skip over? Yes, what is that x value? 0, where the asymptote is, perfect. So I've got to stop at 0. So I'm using a parenthesis, do not use a bracket there. Bracket means equal, and we're not equal to 0. And then union, and then I've got to, on the other side of the asymptote, I start at 0 again, and I go to infinity. So there's my domain. That is just the fancy math way to say, okay, I got to hop over the value of 0. And then the range is very similar. The range, when I'm looking at this graph, my y values, how far down do the y values go? Again, negative infinity. And then as I'm climbing up the y-axis, I notice there is a value I have to skip over. It's the value right here. It's the y value 0, right at sea level. And then 0 to infinity again. So I got to leave out those asymptotes in this case of my reciprocal function. So I would like you just for me to write down what's the domain and the range of exercise 3. So the domain is my left and right on this. So again, it goes negative infinity to the left. But on this particular one, when I'm looking at left or right, what is the x value that I have to hop over here? -2, that's where my asymptote is. We moved that graph 2 to the left. So that's the one that I'm omitting. And then there's no other asymptotes. When we go to the next section, there are rational functions that will have more than one vertical asymptote. So we might have to skip something else. The range, again, it goes down to negative infinity. And then as I'm looking along the y-axis, what's the y value that I have to hop over? -4. Well said. Thank you very much. And so there is my range. Okay, one more. Flip to the second page of this. I've got one more reciprocal function just because I want us to get used to doing this. So the last one, we're not translating left or right or up or down. This time I've got a -2 in the numerator. So just take 10 seconds, theorize. What does that -2 in the numerator say that you are going to do with this graph? Okay, what's the -2? What are you going to do to this graph with the -2? I'm sorry? No, I'm not going to start the graph at -2. Close. I'm going to multiply something by -2. And multiply the y's, because basically what this is we took the 1/x function and now we multiplied it by -2. Okay, when I multiply things, I multiply my numerators, I multiply my denominators. So 1 times -2 would give me -2, and x times 1 gives me x. So this is, I'm going to multiply all the y values by -2. All right, so I'm going to give you a moment to do that. I'm going to reproduce the table just to demonstrate for you. If you don't need the table, then don't write down the table. That's fine. Do whatever it takes for you to be able to reproduce this new graph. Okay, so I've just reproduced my table again. If you don't need to, if you're starting to remember those points, that's great. So I'm just reproduced this because now I'm going to make a column for -2 times the y values just to go through. And if you need to use your calculator, go ahead and do that. But -2 times 0.5 is going to give me -1. -2 times 1 is -2. -2 times 2 is -4. -2 times undefined is undefined. -2 times -2 is 4. -2 times -1 is 2. And then finally, -2 times -½ is 1. So now I'm going to plot those points. It's going to be just what we had before, except now all the y values are multiplied by -2. So at the x value 2, I now go down to -1. At the x value 1, I now go down 2. At the x value 1/2, I now go down 4. Since we have we've not moved the graph, we've not translated it left or right or up or down, the asymptotes do not change. So this is the right half of the graph right here, just looks like something like that. And then my vertical asymptote, we're undefined here, so I'm just going to make a cute little dotted line. Can't go through that, ever go through that. Since we're doing that, I'll just go ahead and I'll make my horizontal asymptote. And then finally, on the left side of this, when I go back 1/2, I go up 4. When I go back 1, I go up 2. And finally, when I go back 2, I go up 1. And so here is the other part of this. So notice I've done two things. When I've multiplied by -2, I've stretched it out. And I've also reflected it about the x-axis. That's what the negative did for me. These right here are just my basic graph. I just reproduced the basic graph table from the previous page. Okay, so when I put 2 in, 1/2 is 0.5. When I put 1 in, 1/1 is 1, etc. And I did that just so that I could multiply all those y values by -2 and do that right there with my calculator. All right, so that is our first new basic function. Practice, practice, practice with that, please. Okay, the second basic function for the day, and there's only 2 new ones in this unit, so not too shabby. We're going to now graph the reciprocal of the square function. Okay, so again, I'm going to make a cute little table. I'm going to actually pick the same x and x values as we did before, and we're going to see what happens to this when I do the reciprocal and I also square it. So I've got 2, I've got 1, I've got 1/2, 0, -1/2, -1, -2. Same exact x values, absolutely no different than it was before. So notice for my reciprocal square function, I am taking whatever x I plug in, and I'm doing 2 things. I'm putting it in the denominator, and I'm squaring it. So when I put 2 in, what happens when I take 2 and put it in the denominator and I square it? What do I get? Yeah, I get 1/4. That's perfection, and we're off to the races. 1/4. When I put 1 in, what happens when I take 1 and put it in the denominator and square it? I get what? 1/1, or just 1. Great. Let me make that 1 a little more definitive. When I take 1/2, and I take 1/2, and I put it in the denominator and I square it, what's my final result? Sorry, what was that? Okay, it's not going to be 1. I think I heard the right answer, but I only heard one person, which is a little frightening to me. So here we go. I've got f of 1/2. So that means what I'm going to do is I'm going to take 1/1/2, and I'm going to square it. Well, 1/2 squared, in case this is where your trouble is coming from, I'm going to just do my scratch work right here. 1/2 times 1/2. Multiplying fractions mean I multiply tops and I multiply the bottoms. When I multiply the tops, I get 1. When I multiply the bottoms, I get 4. So I have 1/1/4. So that's the reciprocal of 1/4, and somebody said it, and I appreciate it. The reciprocal of 1/4 is 4. So when I put 1/2 in, I end up with 4. Once again, when I put 0 in the denominator, I'm undefined, so it looks like we're going to have a vertical asymptote there. And then these values right here, when I put negative a half in, well, first off, let's not worry about the half part. When I square a negative number, what do I get? Positive. So these are all going to be the same results. When I square a negative a half, I get positive a fourth, and then it's the reciprocal. It becomes 4. When I take a negative 1 and I square it, I get 1, and 1 over 1 is 1. When I take a negative 2 squared is 4, and 1 over 4 is 1 over 4, 0.25, if you prefer decimals. So there's my points. So now I'm going to go ahead and I'm going to plot these points. I go over 2, I go up a fourth, so just a little bitty bit. Over 1, up 1. Over a half, up 4. Backwards, I've got negative a half and up 4. Negative 1 and up 1. And then negative 2, up a fourth. So here's what this one looks like. Once again, I got a vertical asymptote on the y-axis, and then the rest of the graph looks like this. It's just kind of the same sort of shape, just stretched out as the last graph. It never goes through the x-axis again, so that is also a horizontal asymptote. If you like old school video games, to me it looks like the Atari symbol. So there we go. So that's the second basic graph you have to be familiar with for this unit. So in an effort to help you get familiar with it, once you've done that, once you've asked any questions that you possibly have, I would love them. Then I would like you to do exercise 5. I'm not going to ask you to tell me what that's doing. I'm assuming that you've picked up on it from the last ones we did. So I want you to graph 1 over x squared and then minus 5 on the side. Yes. Yes, that asymptote stayed the same. I didn't. Let me get a better color to see if I can make it stand out. But yeah, since it's undefined at the x value 0, I have a vertical asymptote right here at the x value 0. And then once again, whatever value you put in the denominator and square it, it's still going to be a number down there. So you're always going to have even the smallest of fractions. So this is going to be a horizontal asymptote right here. So I think you can kind of see that. What is the -5 doing to this graph? Perfect. Well said. It's making it go down 5 units. Great job. Okay, so since it's out on the sides, going down 5. So here goes. I'm going to take my basic points. I'm going to move them all down 5. So instead of being a positive 0.25, it's going to be down here, be negative 4.75. Instead of a 1, it's going to be a negative 4. Instead of a 4, it's going to be down here at negative 1. My horizontal asymptote is also going to move down 5. So I'm going to make a nice purple dotted line down here. The vertical asymptote, I've not moved this left or right at all. So the vertical one is going to stay right where it is. And so here is the right side of the graph right there without going too far and making a big mess of it. And then on the other side, the same thing, goes down, and then finally goes down. And so here's the right side of the graph. Woo. All right, so I've got one more for you to do, and then I've got just a couple bits of trivia about this graph to talk about, and then we're done with section 1. So here, 2 things are happening to this graph. Notice there's the +3. I think we're probably pretty settled on what that's doing. But don't forget that there's a negative out in front of that x squared. So you have to take that into account when you do your graph. So give it a try, and then we'll talk about it. Okay, so this graph is doing 2 things. I think we would all say the +3 is going to move my graph up 3 units. That's great. What is this minus? What do I have to do to account for the minus in front of the 1 over x squared? Yeah, either way you think about it, either flip the graph around the y-axis or you multiply the y's by -1. It's the equivalent thing, however your brain is remembering it. So I'm just going to write down multiply the y's by -1 right there. Which I'll write so you can see it. Now, remember when we multiply, my advice to you all along has been do the multiplication first as a separate step. It makes the problem a lot easier. So what I'm going to do first, I'm just going to do this in black. I'll make it a dotted graph so that I don't make this too much of a big mess. I'm just going to take all of these y values and make them negative. So instead of a positive 0.25, it's a negative 0.25. Instead of a positive 1, it's a negative 1. Instead of a positive 4, it's negative 4. Same thing on the left side. Positive 4 becomes negative 4. Positive 1 becomes negative. And then positive 0.25 becomes negative. Haven't moved the asymptotes at all because we have not shifted the graph. We just did a little multiplying. So here is the left side, just nice and dotted, and the right side, nice and dotted right there, just to kind of give us the feel for what's going on. Then I'm going to take that graph right there, that dotted black graph, and I'm going to move that up 3 units. So when I move it up 3 units, my horizontal asymptote is also going to go up 3 units. My vertical asymptote's not going to change since we have not moved this left or right at all. So I'm just going to go ahead and make my dotted line right there. And now I'm going to move that black graph up 3 units. So here goes. This one goes 1, 2, 3. So nice blue dot right there. 1, 2, 3, blue dot right there. And then 1, 2, 3, blue dot right there. So the left side of this graph, I think it's okay. I don't think I've made too big of a mess of it. More or less, you can see it there. And then the right side of the graph, the same thing, up 3 units, up 3 units, and then finally up 3 units. And there they go. Okay, before we flip this video off, and we're just going to get a very small start to the next section, I just want to ask the same couple questions about the reciprocal square graph that we asked about the reciprocal graph. So I'm going to go up to the basic function right here at the top. So looking at this visually, is this an even function? Yes. Remember, even means symmetric about the y-axis. It means I can fold that in half. You got the same thing. So this one here is even for sure. Then the domain and the range. Well, the domain is just like the reciprocal function. There's only one x value that gives me an undefined. I've got to skip that x value 0. So I go from -infinity to 0, union 0 to infinity. Okay, you can see that. But the range is a little more interesting on this one than the previous graph. What's the lower limit of the y values? How far down do they go? Also, it's never going to equal 0. Okay, that's why it's an asymptote. So I'm going to put a parenthesis there. That's important. And then you can see by the graph, the y values are going to continue to go up forever. So just like that. So the last thing I'm going to ask you to do on this page before we call it quits on section 1 is for exercise 5, if you could just identify the domain and the range of that, please. Okay, so the domain, if you just humor me with this question, is I'm looking left or right. What is the value I have to skip as I go left or right? Okay. I'm sorry? 0. Okay, I thought somebody said negative something, and maybe you did or misheard, whatever. Yeah, you skip 0 right here in the middle. So it's -infinity to 0, union 0 to infinity. Perfect. And then what is the lower limit of y values on this one? Okay, -5, and then the upper limit goes forever. And then don't forget, you should have a parenthesis at the -5. It should not be equal on that side.